Today I am going to talk about friction factor calculation by MATLAB using Colebrook equation. Colebrook equation is given here along with other data like diameter, roughness, height, fluid density, dynamic viscosity, fluid velocity. V is equal to 1 meter per second. So you know that Colebrook equation is a nonlinear equation. So f can be found by a root finding method. Here I am using Newton-Raphson method to find root of the equation, or f can be found by inner method. Now what is Newton-Raphson method? So here is the Newton-Raphson method. So small f n plus 1 is equal to small fn minus capital F of fn by derivative of capital F of fn. So from Colebrook equation we got capital F of small f, and derivative of f can be found by central difference approximation. So here is the central difference approximation. So f is equal to capital F plus h minus capital F minus h by 2h. So now here h is a very small real number and h is 0.001. Now coming to that MATLAB code here. So here CLC means clear skin, and then here I am giving all these data. D is equal to 0.1, that is diameter. E is 0.0015, roughness, height, rho, mu and velocity. And then first calculate Reynolds number, because Reynolds number is there in that equation. So first calculate Reynolds number. So Re is equal to rho dV by mu, and then we for Newton-Raphson method we need guess value. So guess value here is 0.02. So if you take some other value, so that iteration will be more or less depend on guess value. So here I am taking guess value 0.02, and h is very small value, small real number value, so that is 0.001, and then this is the function. So this is the Colebrook equation, and then we are taking here I am giving maximum 10 iteration. So for that iteration we are using for loop. So here for I is equal to 1 to 100, and then in the inside the for loop first evaluate that function value that is f of f, and then next we are going in MATLAB we are going to calculate central difference. By using central difference we are calculating the derivative of the function. So df is equal to capital F of f plus h. So here minus f of f minus h by 2 into h. So after that we use Newton-Raphson method. So f is equal to, or that is root finding method, Newton-Raphson method. So we are applying here. So from this formula we will find the root. So f is equal to f minus f of f by df. Now after that we are displaying the result. So what are the number of iteration, then all the parameter, and then here is the result. So f of f or numerical derivative, then root from the Newton-Raphson method, everything. And last we are putting the breaking condition. We can also put in that breaking condition before the display, but for getting good result or displaying good result, so we are putting display before. So here if absolute value of f of f less than 1 e to the power minus 3, so that is the breaking condition. So that for loop will break and it will end. Now if you run that, so for that you can press F5, so that is you can run, and after that you will get the result here. So this is the function, and then this is the function, and then iteration. So first iteration show all this data and result. So when we take the guess value 0.2, so f will be 2.3241, and after doing the Newton-Raphson method, so f will be 0.0330959. Iteration 2, so that root whatever we got from the iteration 1, so that will be the guess value next iteration. So after the same way, after doing the calculation, so we got the root value is 0.041961. so iteration 3 again, same way, all these parameters are given here, and that MATLAB will calculate, and after that from the Newton-Raphson method, root will be 0.004071, and iteration 4 after taking that is the guess value, so iteration 4 the root will be 0.004154. and if you see that iteration 4 and iteration 3, if you see that f of f is rich, and that is less than 1 e to the power minus 3, so that iteration